so we have section 7.3 that we have to go over. If you recall, 7.1, we were dealing with rational expressions and just basically how to simplify them. In 7.2, we learned how to multiply and divide. And we did the four corners, and then you canceled out each of the matching factors, one on top and one on the bottom. Division was that copy, change, flip, and then you did multiplication. Well, before we get into addition and subtraction, we have to talk about LCD. So 7.3 is all about LCD and raising fractions to a common denominator. You might be saying, why do I need to know LCD? Well, let's take a look at this problem here. 2/3 plus 5/9. 2/3 plus 5/9, I hate to say, you cannot add them. I know some people are saying, well, can't you just do 2 plus 5 is 7, and then 3 plus 9 is 12, and say your answer is 7/12. When it comes to addition and subtraction, you have to have the denominators the same. Basically, what we would tell you in Math 055 is the denominators tells you how big something's cut up into. Think of these as two pizzas. This one was cut up into thirds. This one's cut up into 9 slices. So if you have the same amount of pizza, it's hard to compare a slice that's a third versus a slice that's a ninth. Ninth would be a very small slice of pizza versus third would be a very large. To add and subtract, they have to have the same size. And the only way to get the same size is to find an LCD. So anytime you see addition or subtraction, you need an LCD. Multiplication, division, could care less, only with addition and subtraction. Now, most of you probably recognize that you could use your common denominator of 9. If you didn't know that it's 9, a lot of you learned how to do this as a multiples table, where you would take each of the numbers and you put it on the side, 3 and a 9, and then you would multiply it by 1, by 2, by 3, kind of like what you would see in your notebook on the back, like a black and white, a times table. And then 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. If you're not good at multiplication, it's just basically I'm adding 3 to each of these answers. And then here, I'm going to add 9 to each of these answers. If you didn't know that 1 times 9 is 9, 9 times 2 is 18, or just do 9 plus 9 is 18, 18 plus 9 is 27. And then what you're trying to do is find the lowest number, or the least number that they have in common. So they have 3, 6, 9, 9, 18, 27. You can see that what they have in common is 9. So then in this case, our LCD is 9. The problem with this method is that we are not dealing with just numbers. We are dealing with variables. We're dealing with rational expressions, not fractions. So because of that, we're going to have to teach you the factoring method. Now, the factoring method is basically what we have here. The factoring method says the first thing you want to do is factor all the denominators completely. Remember how to factor out. Always look for a GCF first. Once you take out the GCF, now this is something a little different. If you found the GCF, we'll talk about this a little later. You want to break that down as a tree diagram. But for right now, GCF, then count the number of terms. If you had 4 terms, you do grouping, 3 terms short, arch or FOIL, whatever applies. 2 terms, difference of squares. And if it's 1 term, a monomial, you would do a tree diagram. So once you factor completely, then your second step for the factoring method of finding LCD is to create an LCD list. Basically, you list all the different types of factors in a list. And then we're going to play the versus game. And the versus game is basically this. Each factor that you have, you need to have an amount. And that amount is based on how many that you see in each of the denominators. If it shows up 2 times in one denominator and only 1 time in another denominator, what you have to do is grab the largest amount. That large amount, 2 versus 1, the 2 will become your exponent. And then you can multiply your LCD list out to get your LCD. Let's try to do this, just this, doing these steps. The first thing it says is factor out the denominator completely. Now you know 3, you can't break that down. 9 is a monomial, so we don't look for a GCF. All we would do is then say, okay, that's 3 times 3. To do an LCD list, we would write down LCD. And notice the only factors that we have are 3's. So we would only write it down here one time because there's only one type here, monomial 3. These are duplicates. I always tell people this is kind of like doing a shopping list. You ask your mom what she needs. If she says eggs, you put in the list eggs. If Dad says eggs, you don't write down the word eggs again. Then you'll just write down, oh, it's already on the list. And then you figure out how many you need. If Mom says I only need 1, but Dad says 2 packages will do, you grab the largest amount. So for 3's, notice there's 1 here, but 2 here. So when you play the versus game, 1 versus 2, the largest amount is 2. The amount goes as an exponent. Now this was an easy problem because there's no other factors. And then if you multiply this out, 3 squared, when you multiply out, is your LCD 9. Most of you saw 9 either for here or by just looking at it. Let's go to one that has letters though. So it's not as easy to see it when they have letters. So let's figure this out. And we have to do it the factored method because it has letters. So the first thing that we're going to do is because they're monomials, we have to factor them completely. To factor completely with one term, you know that you're going to do the tree diagram. So for 40, most of you probably would have done 8 times 5. 8 is 2 times 4, and 4 is 2 and 2. Remember, you're trying to get nothing but factors. And then a squared, that would be just writing out twice, a and a. Now let's do a tree diagram for 12a to the 5th. Again, tree diagram, so 4 times 3, and then 4 is 2 and 2, and then you're trying to just get all the prime numbers. So we know that we get 2, 2, 3, and then a to the 5th, that'd be 5a's. Now you'll start realizing you don't have to write all these a's out, but once you factor out each of the denominators, right, that was our first step, factor out each of the denominators, we know that it was one term, so that's why we did a tree diagram. Then what we're going to do is create our LCD list by writing down each of the different types of factors. So notice I write LCD, and my different types of factors are 2's. So I just put it down as 1. Even though there's multiple 2's up here, just write it down one time. We're only writing down each of the different types. If there's a duplicate, don't write it down twice. Duplicate, don't write it again. Do I have a 5 in the list? No. So put in a 5 in the list. Do I have an A in the list? No. So put an A in the list. Do I have another A in the list? Notice that A is already on there. Don't put a duplicate there. Then look at the other denominator. See if that has anything new. Do we have a 2 in the list? Yes. Do we have another 2 in the list? Yes. Do you have a 3 in the list? No. So we're going to have to put that in the list. For the A's, notice, just by having this one A, that's enough. I'm just writing down each of the different types. So this is made up of 2's, 5's, A's, and 3's. Once I have the different types, kind of like going to the supermarket. If this person said, oh, I need 3 gallons of milk, 1 bread, 2 sodas. Here this person says 2 milks, eggs, sodas. Well, then you got to figure out how many you're going to buy. And to figure out that, once you create your LCD list, in each of those guys, we need to have an amount. which is going to be our exponent. We do that by playing the versus game. Again, for each of the different factors, count how many of that term shows up in each denominator. So let's look at the 2's. How many are shown up in this denominator? 1, 2, 3. How many are shown up in this denominator? 1, 2. So 3 versus 2, we told you what you want to do is grab the largest amount. Okay? So 3 versus a 2, largest amount is a 3. Where do I put that 3? As an exponent. Now how about the 5's? Let's see. There is 1 in this denominator, but none here. So 1 versus 0, grab the largest amount. You always will have a number up here. It cannot be 0. Okay? By having it in the list, there has to be a number here. 1, 2, 3, whatever. So 1 versus 0, I still have to use 1 because that's the largest amount. For A's, 2 versus 5, largest amount would be 5. So this is why I'm saying that you didn't really have to write this out, because you could say, well, I have A's here, I have A's here, 2 versus 5, without writing it out. You could have done it that way. And then for 3's, notice there's none here, but there's 1 here. So 0 versus 1, you need at least an exponent of 1. Now with all this here, it looks a little confusing. So we told you your next step is to multiply the LCD list to get that LCD. So you know 2 cubed, 2 times 2 times 2 is 8, times 5 is 40, times 3, 120. And then a to the 5th, just tack it on to the end. So looking at this denominator and this denominator, your LCD is going to be 120 a to the 5th.